Hi, today we're going to do some video practice problems for lesson 3.7, and we're going to do problem number 4, we're going to do problem number 18, and we're going to do problem number 28. So if you need to fast forward through the video to get to a certain problem, go ahead and do that. Number 4 says, find a cubic polynomial in standard form with real coefficients having the given zeros. Let the leading coefficient be 1. You do not use a calculator. Alright, so if we want to write a polynomial that has those zeros, what we're going to do is we're going to start off by writing them back into factors. When you write into factors, you start off with x minus, and then you go ahead and place the 0 in after the minus sign. So in this case, it's negative 9. So we're going to write x minus negative 9. We're going to write x minus negative I. And we're also going to write, because we know that imaginary numbers come in pairs, the conjugate is also a 0 of this problem too. The conjugate of negative I is positive I. So we're going to have one more factor here, and it will be x minus, and then you place the I into the factor. Okay, so we're going to be multiplying all these together. Let's condense these minuses, because when you put two negatives together, it makes a positive. So this is going to be x plus 9. And the next factor is going to be x plus I. And the next one is x minus I. Okay, we're going to go ahead and multiply these factors together. Now remember, you can only multiply two factors at a time. I'm going to choose to multiply the conjugates together first, because that'll eliminate the i's right away when you multiply the conjugates. So this x minus, or this x plus 9 just kind of stays out in the front for a moment. And I'm going to go ahead and multiply or FOIL these two binomials together. X times x is x squared. X times negative I is negative ix. Positive I times x is positive ix. And then we have positive I times negative I, which is negative I squared. Alright, so we need to simplify some stuff in this second factor. We have x plus 9 times, I'm going to change colors here. We know we can cancel out a positive ix and a negative ix. We know that I squared is negative 1. So if you multiply negative 1 times a negative 1, which is in front here, then that makes a positive 1. So that means that when we multiply, or when we simplify this factor, it's going to be x squared is still there, but this turns into plus 1. We're going to multiply these two factors together, so we're going to have x times x squared, which is x to the third power. We have x times 1, which is 1x. We have 9 times x squared, which is 9x squared. And we have 9 times 1, which is 9. We look and see if there's any like terms to put together. Exponents are 3, 1, 2, and 0 for this x on the end here. Nothing to add together. We just want to make sure we write it in highest power to lowest power. So that would be x to the third power plus 9x squared plus x, and then plus 9. If you notice, this polynomial has a leading coefficient of 1. And it says let the leading coefficient be 1. And this polynomial will go through the given zeros. And it has a leading coefficient of 1. And that concludes problem number 4. Now we're going to move on to problem number 18. For each polynomial, one or more zeros are given. Find all the remaining zeros. So this one's got to find all the remaining zeros. Looks like they're giving us negative 5i as a 0. So we're going to take negative 5i and we're going to synthetically divide that into the polynomial p of x, which the coefficients are 2, negative 2, 55, negative 50, and 125. Now, I want you to realize on these, as you're doing these though, it is definitely helpful if you put some 0 i's in here. You've got to know that there's no i's attached to this 2. There's no i's attached to this 2. There's no i's attached to 55. And there are no i's attached to negative 50. And there's no i's on 125. So as we start to multiply this out, you got to keep in mind you're supposed to line these up correctly. So for instance, the first term down here, we know it's coming down, and it happens to be just the number 2. There is a 0i there, but it's really meaningless at this point. What is 2 times negative 5i? It turns out to be negative 10i. Well, I'm going to put the negative 10i underneath the 0i, because that's the like term it goes with. This negative 2 just comes down, and 0i and negative 10i makes negative 10i. Next, we're going to take this negative 5i and we're going to distribute it through to this number down at the bottom. So negative 5i times negative 2 makes positive 10i. Now I'm going to put positive 10i underneath the 0i. I'm then going to take negative 5i times negative 10i, which makes positive 50i squared. Now you got to remember that I times I is I squared, and what is I squared? It's negative 1. So a positive 50 will turn into a negative 50 because you had I squared there. So I'm going to put negative 50 underneath the 55. So 55 minus 50 is 5. And 0 and 10i make 10i. All right, we're going to do it again. 5 times negative 5i is negative 25i. And I'm going to put it underneath the 0i. And then we have negative 5i times positive 10i, which is negative 50i squared. And since I squared is negative 1, it's going to turn negative 50 into positive 50. Well, negative 50 and positive 50 cancel. 0i and negative 25i make negative 25i. And then negative 5i times negative 25i. Well, negative 25 times negative 5 is positive 125. But I squared again is going to take that positive 125 and make it negative 125. And positive 125 and negative 125 make 0. And we completed our first synthetic division. Now, what we got to remember at this point is that if they gave us negative 5i as a 0, then we also know that positive 5i is a 0. And we know that because the i's always come in pairs. They always come in conjugates. So if negative 5i is 0, so is positive 5i. So I'm going to take this line now, and I'm going to synthetically divide it by 5i. And this one's already kind of set up with the i's involved. The only thing we don't have maybe is a 0 right here. There is a 0 in front of this negative 25i. And we got to realize that that was a remainder of 0. There's really nothing there. So I'm going to take and I'm going to draw a line all the way across. And we're going to bring this first coefficient down. 2 times 5i is 10i. Look at that. They cancel. The only thing left is negative 2. Negative 2 times 5i is negative 10i. Ah, look at that again. The negative 10i and positive 10i canceled. The only thing left is 5. And 5i times 5 is 25i. Oh, look at that. The i's cancel again. The only thing left is 0. And that's your remainder. Now, we are asked to find all the remaining zeros. And what you got to think is, synthetically, we used to have 2x to the 4th power right here. When we divided it, this got us down to 2x to the 3rd power. When we divided again, this got us down to 2x to the 2nd power. So this polynomial technically is 2x to the 2nd power minus 2x and plus 5. Now what we're going to do is we're going to take that polynomial And we're going to find all the remaining zeros by solving it. Your choices are, you could try to factor. You could try to use the quadratic formula. I'm just going to go ahead and go to the quadratic formula here, and because it solves everything. And I'm going to set it up. So we got negative b, so that would be positive 2 plus or minus the square root of b squared, which would be negative 2 squared. We have minus 4 times a times c. I'll make sure my square root's all the way across here, all over 2a, which is 2 times 2. That leaves us with x equals 2 plus or minus the square root of negative 2 squared is 4, and 4 times 2 is 8. 8 times 5 is 40. So we have 4 minus 40, and 4 minus 40 is negative 36. And that's all over 2 times 2, which is 4. Now at this point, we're going to simplify this down. This is 2 plus or minus. The square root of 36 is 6. The square root of negative 1 is I. And all that is over 4. And we have x equals, we're going to reduce this down because they're all divisible by 2, so we're going to reduce. That's going to be 1 plus or minus 2 or 3i all over 2. Okay, so let's make sure we answer the question here, okay? I'm going to go ahead and change colors one more time. We'll put it on black here. I'm going to go ahead and list out all the zeros for this problem. The ones they gave us and everything. So let's find all the remaining, but we'll list out every one of them. They gave us negative 5i. We also concluded that positive 5i was a 0. We also found that we have 2 of them right here. We have 1 plus 3i divided by 2. And we also have 1 minus 3i divided by 2. Now if you notice at this point, we have 1, 2, 3, 4 zeros. The degree of the polynomial from the very top was 4. And at least that makes sense as to how many zeros we're supposed to have for this particular question. And that completes number 18. Now I'm going to go ahead and box this. I'm going to go ahead and box this answer down here nice and neat. And it looks just like this. And it's complete. Alright, the last problem we're going to do is number 28. Find a polynomial p of x of least possible degree having real coefficients with the given zeros. Let the leading coefficient be 1. The zeros are 1 plus 2i and 2, which has a multiplicity of 2. What we're going to do is we're going to find p of x, and we're going to do that by changing the zeros back into their factors. 1 plus 2i is x minus, that's how you start off the factors. Then you're going to write 1 plus 2i, and you're going to close the little set of parentheses and close the big set of parentheses. And we're going to know also that conjugate or imaginary numbers come in conjugates, they come in pairs. So if 1 plus 2i is a 0, so is 1 minus 2i. And we're going to close those sets of parentheses. And then we also have some more factors here. We have 2 as a multiplicity of 2, which means the factor is x minus 2. And the other factor is also x minus 2. Oop, let me fix that there. We have x minus 2. Okay, so what we're going to do is we are going to distribute this minus sign through, and we're going to distribute this minus sign. So we have, whoops, let me try it one more time. We have x minus 1 minus 2i times x minus 1 plus 2i. And I'm going to go ahead and start multiplying these factors together. This is x times x, which is x squared. X times negative 2, which is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Alright, so let's see. We're going to go ahead and we're going to multiply this x by every term in the second parenthesis here. So we have x times x, which is x squared. We have x times negative 1, which is negative x. We have x times 2i, which is 2ix. We're going to take the negative 1, we're going to distribute it all the way through. So negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And negative 1 times 2i is negative 2i. We're also going to take the negative 2i and distribute it all the way through. Negative 2i times x is negative 2ix. Negative 2i times negative 1 is positive 2i. And negative 2i times positive 2i is negative 4i squared. Now I'm going to close that parenthesis. In the second one, I'm just going to go ahead and put these two like terms together, which is going to be x squared minus 4x and plus 4. Alright, I'm going to change colors here. And let's go ahead and cancel out some things that are supposed to cancel out, like positive 2ix and negative 2ix. Negative 2i cancels with positive 2i. Let's put everything else together that we possibly can. For instance, the x squared does not have any other like terms in here. Minus x and minus x right here make minus 2x. And we have a positive 1, which is going to go with this term here because we know that I squared is negative 1. So negative 1 times negative 4 is positive 4. So positive 4 and positive 1 make positive 5. We're going to close that. And I'm going to go ahead and bring down the second polynomial, which is x squared minus 4x plus 4. And we're going to do this multiplication again. So this time we have x squared times all three of these terms. So x squared times x squared is x to the 4th power. X squared times negative 4x is negative 4x to the 3rd power. X squared times 4 is 4x squared. Negative 2x times x squared is negative 2x to the 3rd power. Negative 2x times negative 4x is positive 8x squared. And negative 2x times 4 is going to be negative 8x. And we're going to take the 5 and distribute it all the way through. So that's 5x squared. 5 times negative 4 is negative 20x. And 5 times 4, which is 20. Yay! All we have to do now is combine all our like terms that are possible. X to the 4th, are there any more? No. This is the highest power, and it's the only one there. X to the 3rds, we have negative 4 and negative 2, which makes negative 6. And that looks to be it. Negative 6x to the 3rd power. Squares, we have 4 and 8, which is 12, and 12 and 5, which is 17. So we have plus 17 x to the 2nd power. We have x's. We have negative 8 and negative 20, which makes negative 28x. And we have this lonely little plus 20 at the very end, which is our constant. I'm going to go ahead and bring down p of x on this side. I'm going to get my boxing tool here because we just found p of x. And P of X is, oh no. All right, so let me try that one more time up here. And we got it done. All right, so let's just make sure we answered the question here. Find a polynomial P of X of least possible degree. We found there were 1, 2, 3, 4 zeros to this problem, which means the degree has to be 4. Let the leading coefficient be 1. Oh, there it is. We have a 1 right in front. And this problem is complete.